So the question is, show the exponential representation of cosine theta. That sounds a little awkward at first. Basically, you have to know a couple things. You have to know this relation right here, as well as what an imaginary number is, namely j squared is -1. So then j is simply the square root of -1, which in real numbers is impossible, but that's where we have imaginary numbers. They help us with certain computations. Anyhow, if you don't know this, how to derive this, that's different. That's basically it's the Taylor expansion of sine theta and the Taylor expansion of cosine theta. Rather, the Taylor expansion of j sine theta. And when you add them together, you get the same exact expansion of the exponential function e to the j theta. Anyhow, back to the question, exponential representation of cosine theta. At first I was like, what the heck? I had to think about it for a second, but it's pretty simple. Basically, we want to get cosine theta by itself. So let's do that. We have cosine theta. It's going to equal e to the j theta minus j sine theta, because we're just going to subtract j sine theta from both sides. Okay. Now that's all good, except this is not an exponential form. So we're going to do that over here. You have to be a little bit clever. Basically what you want to do is you want to say e to the negative j theta is going to equal cosine theta minus j sine theta. And I'll explain that. This minus j here gets projected in the expansion, and ultimately you get a minus j sine theta here, where in the original one it's a plus j and you get a plus j. So here you put a minus j and you get a minus j. What that's going to do for us is we're going to solve for minus j sine theta. So basically minus j sine theta is equal to e to the negative j theta minus cosine theta, which looks good. What we're going to do is we're going to take this entire term and we're going to put it here to replace this. To replace this whole thing. Let's do that. Let's use black. So we have cosine theta equals e to the j theta, and then this term we'll replace it with just this part. So that's plus e to the negative j theta minus cosine theta. We're going to bring this over here because of addition, and we get 2 cosine theta equals e to the j theta plus e to the negative j theta. We're going to divide by 2 here, and get that, cross this 2 out, and here's your answer right here. Pretty simple. And to check it, we're simply going to put a check. And that's how you get the exponential representation of cosine theta.